September 27, 1942. Richmond, California. Kaiser Shipyard Number 2. The keel was laid at 12:01 a.m. By noon, the hull sections were being welded together. By evening, the deck sections were being lowered into place. By the next morning, the superstructure was being assembled. By the afternoon of the fourth day, the SS Robert E. Peary was ready for sea trials. 4 days, 15 hours, 30 minutes from keel laying to launch. A Liberty ship, 10,000 tons displacement, 441 feet long, 57 feet wide. Capacity, 10,000 tons of cargo, or 2,840 troops, or 440 tanks. Built by welders who had been housewives 6 months earlier. Assembled from prefabricated sections manufactured in factories across California. Launched into the Pacific to face German U-boats in the Atlantic. The Robert E. Peary was a publicity stunt, a demonstration that the impossible had become routine. But the publicity masked a grimmer reality. In 1942, German U-boats were sinking ships faster than the Allies could build them. Britain was starving. The Soviet Union was collapsing. The mathematics were brutal and simple. If the sinking rate exceeded the building rate, the Allies would lose the war. Not through military defeat, through arithmetic. Henry Kaiser had promised President Roosevelt he could reverse the equation. He could build ships faster than U-boats could sink them. He could turn the Battle of the Atlantic from a slow defeat into an industrial victory. The establishment didn't believe him. Shipbuilders said it was impossible. Maritime unions said it was dangerous. Naval architects said the ships would break apart. They were partly right. The first Liberty ships did break apart. Welds cracked in cold water. Hulls split in heavy seas. Ships literally broke in half and sank without enemy action. But Kaiser kept building. He fixed the steel specifications. He improved the welding techniques. He refined the construction process. And he kept building faster. By 1943, Liberty ships were launching at a rate of 3 per day across American shipyards. By 1944, the U-boats had effectively lost the Battle of the Atlantic. Not because Allied anti-submarine warfare improved, though it did, but because the mathematics had reversed. The Allies were building ships faster than Germany could sink them. Arithmetic doesn't care about tactics. It just counts tonnage. And tonnage determines who starves and who survives. This is the story of how American industry turned shipbuilding into mass production. How Henry Kaiser applied Henry Ford's assembly line to the ocean. And how 2,710 ugly, slow, expendable ships won the Battle of the Atlantic before the battle was even fought. Britain was an island that couldn't feed itself. Before the war, Britain imported 55 million tons of goods annually. Food, fuel, raw materials, everything an industrial nation needed to survive. The merchant fleet that carried these goods was Britain's lifeline. Germany understood this. Grand Admiral Karl Donitz had calculated the numbers precisely. Britain required approximately 1 million tons of shipping arriving weekly to maintain minimal operations. Sink enough ships, and Britain would starve into surrender within months. The U-boat campaign began in September 1939. By the end of 1940, Germany had sunk 1,059 merchant ships, totaling 4 million tons. By the end of 1941, another 1,299 ships, totaling 4.3 million tons. The numbers were trending toward catastrophe. Britain was building ships, but not fast enough. Traditional shipbuilding in Britain took 230 days per vessel. American shipyards managed 210 days. Germany was sinking ships faster than the Allies could replace them. The mathematics were clinical. In early 1942, U-boats were sinking an average of 700,000 tons per month. Allied shipyards were producing approximately 500,000 tons per month. The deficit was 200,000 tons monthly, compounding, accumulating, irreversible. British officials calculated that at current rates, merchant tonnage would drop below viable levels by late 1943. The import rate would fall below 1 million tons weekly. Food rationing would become starvation rationing. Industry would slow for lack of raw materials. The war effort would collapse not from military defeat, but from logistics failure. The crisis wasn't theoretical. In early 1942, Britain had food reserves for approximately 12 weeks. If the Atlantic supply line failed, the nation would face mass starvation within 3 months. American entry into the war in December 1941 provided hope. American industrial capacity could build ships, but could it build them fast enough? Traditional shipbuilding methods wouldn't suffice. The math didn't work. If American yards built ships using conventional methods, 210 days per ship, production would increase, but not enough. The U-boats would still win the arithmetic battle. Britain would still starve. The U.S. Maritime Commission understood the problem. They needed ships built in a fraction of the traditional time. They needed construction methods that could scale to dozens of shipyards. They needed mass production applied to shipbuilding. They needed something that didn't exist. They needed Henry Kaiser. Henry J. Kaiser was not a shipbuilder. He had never built a ship before 1941. He was a construction engineer who built dams, bridges, and highways. He knew concrete and steel. He knew project management and logistics. He knew how to organize large projects and complete them ahead of schedule. He didn't know ships. The maritime establishment considered this a fatal disqualification. Kaiser had built the Hoover Dam ahead of schedule. He had built the Bonneville Dam ahead of schedule. He had built the Grand Coulee Dam ahead of schedule. His approach was consistent. Break large projects into smaller components. Prefabricate everything possible. Organize assembly like a factory production line. When the Maritime Commission issued contracts for emergency shipbuilding in 1940, Kaiser applied. The commission was skeptical. Shipbuilding was a specialized craft. Ships were complex, custom-built structures, each one unique. You couldn't build ships like you built dams. Kaiser disagreed. Ships were just floating structures. Structures could be engineered. Engineering could be systematized. Systems could be mass-produced. The establishment scoffed. Shipbuilding had traditions going back centuries. Skilled workers laid keels, shaped hulls, riveted plates together. It was craftsmanship, not assembly line work. But the establishment couldn't build ships fast enough. The mathematics demanded something new. Kaiser received a contract to build 30 cargo ships. The maritime unions protested. He had no experience. His workers would be untrained. The ships would be unsafe. Kaiser hired workers from his dam projects. He recruited women to replace men being drafted. He brought in welders from construction sites, pipe fitters from oil fields, and assembly line workers from automobile factories. Most had never seen a ship except from shore. He applied principles from dam construction. Break the ship into prefabricated sections. Build the sections simultaneously in different areas of the shipyard. Assemble the sections like building blocks. Use welding instead of riveting, faster and required less skill. The first ship took 230 days to build, about average for traditional shipbuilding. The maritime establishment said this proved Kaiser was no better than conventional builders. But Kaiser was learning. Each ship taught lessons. Each lesson improved the process. By the 10th ship, construction time had dropped to 150 days. By the 20th ship, 105 days. The learning curve was steep. The more ships built, the faster construction became. Workers developed expertise. Processes became refined. Bottlenecks were eliminated, and Kaiser kept pushing. Faster, more efficient, cheaper. The maritime establishment watched with growing alarm. This wasn't how ships were built. This violated tradition, ignored craftsmanship, disregarded centuries of shipbuilding practice. But the ships floated. They carried cargo. They crossed oceans. And they were being built faster every month. Then Kaiser proposed something the establishment considered insane. He wanted to build a ship in under 100 days, then under 50 days, then impossibly under 30 days. The establishment said it couldn't be done. Kaiser said, "Watch me." Kaiser's insight was simple. Ships didn't have to be built from the keel up. They could be built from sections, assembled like a puzzle. Traditional shipbuilding started with the keel, the ship's spine. Workers built the ship upward from the keel, adding ribs, plates, and decks in sequence. Everything happened in the shipyard. Everything was sequential. Nothing could be built in parallel. Kaiser inverted the process. The ship would be divided into prefabricated sections. Each section would be built separately, away from the shipyard, in facilities that could focus on one component type. The shipyard would become an assembly facility, not a construction site. The Liberty ship design lent itself to this approach. The ships were standardized. Every Liberty ship was identical. EC2SC1 was the official designation. Emergency cargo, second design, steam engine, cargo type 1, 10,000 tons, 441 feet long, 57 feet beam, simple, ugly, and built for mass production. Kaiser divided each ship into approximately 250 prefabricated sections. The sections range from small deck pieces to entire cargo hold assemblies weighing 70 tons. Factories across California manufactured sections. Inland facilities that had never built ships were producing ship components. A factory in Los Angeles made bow sections. A plant in Oakland made stern sections. Facilities throughout the Bay Area made deck sections, superstructure, bulkheads, and engine rooms. The sections arrived at the shipyard ready for assembly. Hull sections came with frames already installed. Deck sections came with plumbing and electrical conduits pre-installed. The superstructure arrived as complete units, bridge, crew quarters, galley, fully equipped and ready to be lifted into place. Assembly was methodical. Days 1 to 3, keel sections laid and welded. Days 4 to 7, hull side sections attached. Days 8 to 12, bottom hull sections welded. Days 13 to 20, deck sections lowered and welded. Days 21 to 30, superstructure lifted into position. Days 31 to 40, fitting out, installing equipment, piping, wiring. Days 41 to 45, testing and trials. The timeline assumed everything went perfectly. It rarely did, but the average kept dropping as processes improved. Welding replaced riveting as the primary joining method. This was revolutionary and controversial. Traditional ships were riveted, metal plates joined by thousands of rivets driven by skilled teams. Riveting was slow, labor-intensive, and required significant expertise. Welding was faster. A welder could join plates continuously, creating seams in hours that would take days to rivet. Welding required less skill. Workers could be trained in weeks rather than years. And welding was lighter. No rivets meant less weight and more cargo capacity. But welding had problems. Early Liberty ships suffered catastrophic failures. Hulls cracked. Ships broke in half. In January 1943, 3 Liberty ships broke apart within a single week. SS Schenectady split in 2 while docked in calm water. The ship literally snapped in half with a crack that witnesses heard from a mile away. Investigation revealed the problem: brittle fracture. The steel used in Liberty ships became brittle in cold North Atlantic water. Welded seams, unlike riveted joints, provided continuous stress paths. When cracks started, they propagated rapidly through the weld. The entire hull could fail catastrophically. The Navy wanted to halt production. Liberty ships were death traps. The welding needed to be replaced with riveting. Construction would return to traditional methods. Kaiser argued against halting production. The problem wasn't welding, it was steel quality. Change the steel specification. Improve the welding techniques. Add crack arresters to prevent propagation. But keep building. The argument came down to mathematics. Halting production would save lives on Liberty ships, but cost lives in Britain. Ships sunk by design flaws were tragedy. An entire nation starving because ships weren't built was catastrophe. Production continued while fixes were implemented. Steel specifications were changed to prevent brittle fracture. Welders received additional training. Crack arresters were added, riveted straps that stopped crack propagation. The hull design was modified to eliminate stress concentration points. The fixes worked. After mid-1943, catastrophic hull failures essentially stopped. Liberty ships proved tough and reliable. They survived torpedo hits, ran aground and were refloated, collided with each other, and continued operations. The ships were ugly and slow, but they were fundamentally sound, and they kept being built faster. The learning curve was relentless. As workers gained experience and processes improved, construction time collapsed. 1941, average 230 days per ship. Traditional shipbuilding pace, nothing revolutionary. January 1942, average 150 days per ship. Prefabrication beginning to show results. June 1942, average 105 days per ship. Assembly line methods taking effect. September 1942, average 70 days per ship, half the original time. January 1943, average 42 days per ship, less than 1/5 the original time. The improvement wasn't linear. It followed a learning curve where each doubling of cumulative production resulted in approximately 20% reduction in construction time. By the time Kaiser's yards had built 1,000 ships, they had accumulated enough experience that a new ship could be built in 6 weeks on average. But averages masked the extremes. The Robert E. Peary's 4-day, 15-hour record was a publicity stunt, but it demonstrated what was theoretically possible with unlimited labor and perfect coordination. More impressively, several ships were built in under 10 days during 1943 without special arrangements, just normal production schedules that happened to align perfectly. The Richmond shipyard, Kaiser's flagship facility, peaked at launching a complete ship every 5 days on average during 1943. The yard had 7 ways, construction berths. On any given day, 7 ships were in various stages of assembly. Every 5 days, 1 ship launched and a new keel was laid. The workforce numbers were staggering. In 1941, Kaiser employed 10,000 workers across his shipyards. By 1943, employment peaked at 196,000 workers in Richmond alone. The workforce included women, approximately 30% by 1943, African Americans, previously excluded from shipyard work, and workers with no prior shipbuilding experience. Rosie the Riveter, the cultural icon of women in wartime industry, was largely a welder on Liberty ships. Wendy the Welder would have been more accurate, but didn't alliterate as well. These women, many of whom had been homemakers, received 3 weeks of training and then joined assembly lines building ships. The training programs were revolutionary. Traditional shipbuilding apprenticeships took years. Kaiser's training took weeks. The difference was specialization. Traditional shipbuilders needed to understand entire ships. Kaiser's workers needed to understand one task, welding hull sections, or installing piping, or riveting deck plates. Specialization enabled rapid training. Production across all American shipyards reached extraordinary levels. 1941, 230 ships launched, mostly traditional construction. 1942, 746 ships launched, Liberty production ramping up. 1943, 1,949 ships launched, peak efficiency. 1944, 1,490 ships launched, production maintained despite labor shortages. 1945, 396 ships launched, war ending, production winding down. Total Liberty ships built, 2,710 ships between 1941 and 1945. Total tonnage, approximately 27 million tons. Total cost, approximately $4 billion, 1945 dollars, or roughly $70 billion today. Average cost per ship, $1.5 million, 1945 dollars, or $28 million today. Compared to traditional shipbuilding, $3 million per ship. Kaiser's methods cut costs in half while building faster. The numbers represented more than industrial achievement, they represented survival. By 1943, Liberty ships were being launched faster than U-boats could sink merchant vessels. The mathematics had reversed. Britain would not starve. The Soviet Union would receive supplies. The war could continue. The Battle of the Atlantic was fundamentally a race between construction and destruction. Germany needed to sink ships faster than the Allies could build them. The Allies needed to build faster than Germany could sink. 1941 was disaster. U-boats sank 1,299 merchant ships, totaling 4.3 million tons. Allied shipyards built approximately 1,000 ships, totaling 4 million tons. The net was negative. Shipping tonnage declined. Britain's situation deteriorated. 1942 was crisis. U-boats had their happy time, the period of maximum effectiveness. In the first 6 months of 1942, U-boats sank 585 ships, totaling 3.1 million tons. The rate was accelerating. If it continued, Britain would face starvation by year's end. American Liberty ship production was ramping up, but not yet at scale. In the first half of 1942, American yards delivered approximately 300 Liberty ships, about 3 million tons. Combined with British production, total Allied shipbuilding was roughly matching U-boat sinking rates. The balance was precarious. Then the mathematics shifted. July-December 1942, U-boats sank 510 ships, totaling 2.7 million tons. Allied shipyards, now producing Liberty ships at increasing rates, built 700 ships totaling 5 million tons. For the first time, construction exceeded destruction. 1943, the turning point. U-boats sank 463 ships, totaling 2.5 million tons. Allied shipyards built 2,000 ships, totaling 14 million tons. The ratio was 5.6 to 1. For every ship the U-boats sank, the Allies built more than 5 replacements. The German submarine campaign was finished. Not because U-boats became ineffective, German submarines continued to sink ships throughout the war, but because the industrial capacity of the United States had made sinking ships mathematically futile. Grand Admiral Dönitz understood the problem. In a 1943 report to Hitler, he wrote, "The enemy is building ships faster than we can sink them. Even if we doubled our U-boat force and doubled our effectiveness, we would still lose the tonnage war. The arithmetic is against us." 1944 to 1945, mop-up. U-boats sank approximately 200 ships totaling 1 million tons. Allied shipyards built 1,900 ships totaling 13 million tons. The ratio was 13 to 1. The final statistics were decisive. Total ships sunk by U-boats, 1939 to 1945, 2,882 ships, approximately 14.5 million tons. Total ships built by Allies, 1939 to 1945, approximately 5,000 ships, over 40 million tons. The Allies built 3 times more tonnage than the U-boats sank. The Battle of the Atlantic was won by shipyards, not destroyers. This wasn't the narrative most histories emphasized. The conventional story focused on improved anti-submarine warfare, better sonar, escort carriers, long-range patrol aircraft, breaking the Enigma codes, hunter-killer groups. All these factors mattered. They reduced U-boat effectiveness. But even if U-boats had maintained their 1942 effectiveness throughout the war, they still would have lost. The mathematics made German victory impossible once Liberty ship production reached scale. By mid-1943, the Allies could absorb any loss rate the U-boats could inflict and still increase total merchant tonnage. This was industrial warfare in its purest form. The victory wasn't won by superior tactics or better weapons. It was won by superior production capacity. Henry Kaiser's shipyards defeated Karl Donitz's U-boats before the submarines ever left port. The ships just had to be built faster than they could be sunk. Once that threshold was crossed, the outcome was inevitable. Liberty ships were designed as emergency cargo vessels. Build them fast, use them hard, scrap them after the war. That was the philosophy. They weren't meant to be good ships. They were meant to be adequate ships built in inadequate time. They were slow. Maximum speed, 11 knots. A destroyer could do 35 knots. Even a conventional cargo ship managed 15 knots. Liberty ships plodded across oceans at a pace that made them easy U-boat targets. They were ugly. Welded hulls gave them a utilitarian appearance. No elegant lines, no aesthetic considerations, just functional boxes designed to float and carry cargo. They were uncomfortable. Crews called them ugly ducklings and Kaiser's coffins. The accommodations were Spartan. The ships rolled heavily in rough seas. Engine noise and vibration permeated the vessel. But they worked. Liberty ships carried 75% of all cargo shipped overseas during the war. They transported tanks, trucks, ammunition, food, fuel, and raw materials to every theater. They carried troops to invasion beaches. They served as emergency transports, hospital ships, and repair vessels. 2,710 Liberty ships entered service. 200 were sunk by enemy action: U-boats, aircraft, mines, surface ships. Another 80 were lost to storms, collisions, and other marine hazards. 2,430 Liberty ships survived the war. That's an 89.7% survival rate. Some Liberty ships became famous. SS Stephen Hopkins, the only American merchant ship to sink a German surface warship in a gun battle. September 27, 1942, the Hopkins, armed with a single 4-inch gun, fought the German auxiliary cruiser Stier and the merchant raider Tannenfels. Both German ships were sunk. The Hopkins was also sunk, but the crew survived. The armed guard gunner who manned the 4-inch gun received the Navy Cross posthumously. SS Richard Montgomery sank off the Thames estuary in August 1944, carrying 1,400 tons of explosives. Still lies on the seabed today. The wreck is considered too dangerous to salvage. If the explosives detonate, it could cause a 5-meter tsunami and damage London. SS John W. Brown and SS Jeremiah O'Brien, the only 2 Liberty ships still in operational condition. Both are museum ships. The O'Brien still makes occasional voyages under its own power, an 80-year-old ship that can still cross oceans. Many Liberty ships continued serving after the war. The U.S. sold hundreds to foreign nations. Greek shipping companies operated Liberty ships commercially until the 1960s. Some soldiered on into the 1970s. The last Liberty ship in commercial service was scrapped in 1993, 48 years after the war ended. The ships Kaiser built to be expendable proved nearly indestructible. They were hit by torpedoes and kept sailing. They ran aground and were refloated. They collided with each other and continued operations. The simple, crude construction made them remarkably resilient. One Liberty ship, SS Benjamin Conti, was torpedoed by a U-boat in March 1945. The torpedo hit amidships, directly in a cargo hold loaded with ammunition and explosives. The resulting explosion blew a 60-foot hole in the hull. The crew abandoned ship, expecting it to sink within minutes. It didn't sink. The ship remained afloat. A salvage crew returned, patched the hole with concrete, pumped out the flooded compartments, and sailed the ship back to port for repairs. It returned to service 3 months later. That was typical of Liberty ships. They were overbuilt in some ways, underbuilt in others, but fundamentally tough. The welded construction that caused early problems actually proved advantageous in combat. Torpedo hits that would have destroyed a riveted ship often left Liberty ships damaged but functional. Liberty ship production came at a price measured in workers' lives. Shipyard work was dangerous. Welding accidents, falls from scaffolding, crane mishaps, fires and explosions killed workers regularly. The Richmond shipyard alone recorded 87 fatalities during the war years. Across all American shipyards, approximately 500 workers died in construction accidents. The pace of work contributed to the danger. Kaiser's emphasis on speed meant workers were tired, rushed, and sometimes cutting corners on safety. The 3-week training programs meant workers were operating heavy equipment and performing dangerous tasks with minimal experience. Labor unions protested. The conditions were unsafe. Workers were being killed to meet unrealistic production schedules. Kaiser's methods prioritized speed over safety. Kaiser countered that the war itself was unsafe. Every day the war continued, soldiers died in combat. Every ship delayed meant supplies didn't reach the front. The calculus was grim. Accept worker deaths now to save soldier lives later. The argument was morally complicated, but the mathematics were clear. 500 worker deaths during Liberty ship production. Approximately 30,000 Allied merchant seamen died during the war, many of them sailing on ships that arrived too late because production was too slow. Kaiser improved safety where possible. He instituted better training programs. He enforced safety protocols more strictly. He provided medical facilities on site, but he never slowed production. The workers understood the stakes. They were building ships to save Britain from starvation. They were building ships to supply the Soviet Union fighting in the East. They were building ships to carry American soldiers to Europe. The cause was clear. The urgency was real. Many workers put in 60 to 70-hour weeks. Some worked double shifts. The money was good. Wartime shipyard work paid significantly better than most civilian jobs. But the motivation wasn't primarily financial. Workers understood they were part of something essential. One welder, interviewed in 1943, explained, "I know this is dangerous. My friend died last month when scaffolding collapsed. But my brother is in the Pacific. These ships might save his life. That's why I'm here." That sentiment was common. Workers had family members in the military. The ships they built might carry supplies to their sons, brothers, or husbands. The personal connection drove effort that exceeded what financial compensation alone could achieve. German naval officials watched American Liberty ship production with growing alarm. Early assessments were dismissive. The ships were slow, ugly, and poorly built. Intelligence reports noted the hull failures, ships breaking in half without enemy action. German propaganda called them Kaiser's coffins and mocked American shipbuilding incompetence. But the tonnage numbers couldn't be mocked. By mid-1942, German naval intelligence was reporting that American shipyards were producing merchant vessels at rates previously thought impossible. The reports were met with skepticism in Berlin. The numbers seemed too large to be credible. They were accurate. By late 1942, German naval staff had confirmed that American production was exceeding U-boat sinking rates. The implications were discussed in high-level meetings. Admiral Donitz requested more U-boats. If the Allies were building more ships, Germany needed more submarines to sink them. Hitler approved U-boat production increases, but the mathematics didn't work. Building U-boats took time, approximately 12 to 18 months, from keel laying to operational deployment. Training crews took additional months. A U-boat cost approximately $2 million, 1942 dollars. A U-boat crew required 50 trained submariners, a scarce resource. Liberty ships took 6 weeks to build by 1943. They cost $1.5 million. Their crew required minimal training, merchant seamen, not specialized personnel. The production math favored the Allies decisively. Germany could build U-boats, but not fast enough or cheap enough to offset Liberty ship production. Worse, each U-boat lost meant trained crews lost. The Allies could replace ships and crews faster than Germany could replace submarines and submariners. By 1943, German U-boat losses were accelerating. Experienced crews were dying. Replacement crews had less training. Effectiveness declined. A German naval staff assessment from August 1943 concluded, "The enemy's industrial capacity has made the tonnage war unwinnable. We can continue submarine operations to inflict losses and tie down enemy resources, but we cannot sink ships faster than they build them. The strategic situation is irreversible." The assessment was classified and not widely circulated. Admitting defeat in the Battle of the Atlantic would damage morale, but the senior staff knew. The numbers were clear. Donitz continued U-boat operations through the war's end. Submarines were still sinking ships in May 1945, but the operations were tactically focused, not strategically decisive. The goal was no longer to starve Britain. That was impossible. The goal was to force the Allies to divert resources to convoy protection and anti-submarine warfare. German submariners understood the situation. By 1944, U-boat crews knew their life expectancy measured in months. 3/4 of U-boat personnel who served during the war died. It was the highest casualty rate of any German military branch. One U-boat commander, Kapitänleutnant Heinrich Lehmann-Willenbrock, wrote in his diary in 1944, "We sink ships, more ships appear. We sink those, more appear still. The enemy has infinite ships. We have finite submarines. The conclusion is mathematical. We have already lost." Lehmann-Willenbrock survived the war. Most of his peers didn't. Liberty ships represented the ultimate expression of American industrial capacity applied to warfare. The shipbuilding achievement was unprecedented. 2,710 ships in 4 years. Never before had any nation built so many ships so quickly. Never since has any comparable production program been attempted. But Liberty ships were more than just numbers. They represented a philosophy. Adequate solutions produced quickly beat optimal solutions produced slowly. Henry Kaiser didn't build the best ships. He built ships that were good enough, fast enough, and cheap enough. That was the insight. Perfect was the enemy of sufficient. Optimization was the enemy of speed. The approach was controversial. The maritime establishment never fully accepted Kaiser's methods. Traditional shipbuilders considered his ships inferior. Naval architects pointed to the design compromises and construction shortcuts. They weren't wrong. Liberty ships were inferior to properly designed cargo vessels. They were slower, less efficient, less comfortable, and less durable than ships built by traditional methods. But they existed. Traditional shipyards were still calculating optimal hull forms and debating rivet patterns while Kaiser was launching ships. Perfect ships that don't exist don't carry cargo. The Liberty Ship program established principles that shaped post-war manufacturing. Modular construction, breaking complex products into prefabricated modules that could be assembled quickly. This approach now dominates industries from housing to aerospace. Rapid workforce training, bringing unskilled workers to productivity in weeks through specialization and focused training. Modern manufacturing training programs follow similar models. Continuous improvement, using learning curves to drive systematic reduction in production time and cost. Quality management systems today incorporate these principles. Standardization over customization, building identical units rather than custom designs to enable mass production. Modern industry defaults to standardized products with customization options. Scale as a strategic weapon, using production capacity itself as a competitive advantage. Post-war American industry dominated globally, partly through sheer scale. The Liberty Ship program also established Kaiser as an industrial titan. After the war, he founded Kaiser Permanente, one of the first health maintenance organizations. He built Kaiser Aluminum, challenging Alcoa's monopoly. He entered automobile manufacturing with Kaiser Fraser. He developed communities and infrastructure across the American West. His reputation was built on Liberty ships. The man who outproduced the U-boats became synonymous with American industrial might. The ships themselves gradually disappeared. Some sank during the war. Many were scrapped in the late 1940s as wartime emergency ended. Others served merchant fleets for decades. The last Liberty ship in commercial service, SS Arthur M. Huddell, was scrapped in Greece in 1993. Only two survive in operational condition: SS John W. Brown, Baltimore, and SS Jeremiah O'Brien, San Francisco. Both are museum ships that occasionally sail under their own power. The O'Brien crossed the Atlantic in 1994 for the 50th anniversary of D-Day, a 50-year-old Liberty ship proving the basic design was sound. The industrial infrastructure that built Liberty ships was largely dismantled after the war. The Richmond shipyard closed in 1945. Many other yards converted to peacetime production or closed entirely. The workforce dispersed. Rosie the Riveter returned home or found other employment, but the capability remained latent. American industry had demonstrated it could scale to extraordinary levels when necessary. The Liberty Ship program was proof that industrial capacity could be mobilized, organized, and directed to achieve results that seemed impossible. That capability shaped the Cold War. Soviet planners understood that American industrial capacity was a strategic weapon. Any conventional war with the United States would become a production race. The Liberty Ship program demonstrated that America could win production races. The ships were gone. The capability remained. That was perhaps the most important legacy. Statistics that summarize the Liberty Ship program. Ships built, 2,710. Construction period, 1941 to 1945, 4 years. Average construction time, 42 days, 1943. Fastest construction, 4 days, 15 hours, 30 minutes. SS Robert E. Peary. Total tonnage, 27 million tons. Total cost, $4 billion, 1945 dollars, equals $70 billion, 2024 dollars. Average cost per ship, $1.5 million, 1945 dollars, equals $28 million, 2024 dollars. Workforce peak, 500,000 plus workers across all shipyards. Ships sunk by enemy action, 207.4%. Ships sunk by marine hazards, 83.0%. Ships surviving the war, 2,430, 89.6%. Cargo carried, approximately 75% of all wartime overseas cargo. Impact on Battle of the Atlantic, 1942. U-boats sinking rate 700,000 tons per month. Allied construction 500,000 tons per month. Germany winning. 1943. U-boats sinking rate 210,000 tons per month. Allied construction 1,200,000 tons per month. Ratio 5.7 to 1. Allied advantage. Germany losing. 1944. U-boats sinking rate 83,000 tons per month. Allied construction 1,100,000 tons per month. Ratio 13 to 1. Allied advantage. Germany defeated. The reversal occurred in mid-1943 when Liberty ship production reached full scale. The Battle of the Atlantic was decided by arithmetic. The shipyards beat the submarines. Compared to alternatives, if Liberty ships had not been built and traditional construction continued, construction rate, approximately 500,000 tons per month maximum. U-boat sinking rate, approximately 400,000 tons per month, 1942 to 1943 average. Net merchant tonnage, declining slowly. Britain's supply situation, critical shortage by late 1943. Probable outcome, negotiated peace or extended war into 1946 to to 1947. If Liberty ships had been built at only half the actual rate, construction rate, approximately 600,000 tons per month, U-boat sinking rate, approximately 300,000 tons per month, improving, Allied ASW, net merchant tonnage, growing slowly, Britain's supply situation, adequate but not comfortable, probable outcome, war ends mid-1945 instead of May 1945. The actual Liberty ship program produced twice the tonnage needed to sustain Britain. The surplus enabled the Soviet supply route, the North Africa invasion, the Italy campaign, and the D-Day logistics. Strategic flexibility came from surplus capacity. One ship every 5 days from each major shipyard. 7 major shipyards. One ship launched somewhere every 17 hours on average during 1943. That pace won the war. Not through direct combat, through mathematics, through tonnage, through industrial capacity applied relentlessly until the enemy's strategic position became mathematically untenable. Henry Kaiser built ugly ships, slow ships, uncomfortable ships, but he built them faster than the enemy could destroy them, and that was enough. Sometimes adequate, repeated 2,710 times, wins the war. The Liberty ship story teaches a lesson that extends beyond shipbuilding and beyond World War II. Scale matters. Producing adequate solutions quickly and in large numbers beats producing optimal solutions slowly in small numbers. This principle seems obvious in retrospect, but it violated prevailing wisdom in 1941. The maritime establishment believed quality mattered more than quantity. Better to build fewer ships correctly than many ships quickly. Kaiser proved them wrong. Not by building better ships. Liberty ships were objectively worse than traditionally built vessels, but by building enough ships fast enough that quality became irrelevant. The U-boats couldn't sink ships faster than they were built. That was the only metric that mattered. Ship speed, efficiency, durability, comfort, all secondary to construction rate. Modern technology companies have learned similar lessons. Facebook's early motto was, "Move fast and break things." Ship products quickly, even if imperfect, then iterate. Google launched Gmail as a beta product that remained in beta for 5 years. Amazon's Jeff Bezos emphasized speed of decision-making over perfect analysis. These approaches descended intellectually from the Liberty ship philosophy. Adequate solutions deployed rapidly beat perfect solutions deployed slowly. The counter-argument is, quality matters. Rushing leads to failures. Liberty ships did break apart from brittle fracture. Lives were lost. Shouldn't quality have been prioritized? But the alternative was worse. If Kaiser had halted production to perfect the design, ships would have been delivered months later. British import tonnage would have dropped below survivable levels. The war might have been lost while awaiting perfect ships. The calculus was brutal but clear. Accept some failures from speed to avoid catastrophic failure from slowness. This logic applies to crisis response generally. In emergencies, adequate immediate response beats perfect delayed response. During the COVID-19 pandemic, vaccine development prioritized speed. The vaccines weren't perfect, side effects existed, efficacy wasn't 100%, questions remained, but they were deployed in under a year instead of the traditional 5 to 10 years. The Liberty ship precedent: accept imperfection to achieve speed when the alternative is catastrophe. Another lesson: specialization enables rapid scaling. Kaiser didn't train workers to build entire ships. He trained them to perform specific tasks: welding hull sections, installing piping, riveting decks. Task specialization meant training could be compressed from years to weeks. Modern manufacturing follows this model universally. Workers specialize in narrow tasks. Assembly lines break complex products into simple steps. Quality comes from system design, not worker expertise. A third lesson: standardization enables mass production. Every Liberty ship was identical. Same dimensions, same engines, same layout. This uniformity enabled prefabrication, simplified logistics, and accelerated learning curves. Post-war manufacturing embraced standardization. Henry Ford had pioneered it with the Model T. Kaiser applied it to ships. Post-war industry applied it to everything. The final lesson: industrial capacity is a strategic weapon. Military advantage flows not just from superior weapons, but from superior production. The nation that can build more, faster, wins. The Soviet Union learned this lesson. Post-war Soviet military doctrine emphasized mass production of adequate equipment over small numbers of advanced systems. Soviet tanks, aircraft, and ships were generally inferior to Western equivalents, but produced in vastly larger numbers. China has learned this lesson. Modern Chinese industrial strategy emphasizes scale and speed. Quality improves incrementally, but volume provides strategic advantage. The United States, ironically, sometimes forgets the lesson it taught with Liberty ships. Modern American military procurement often prioritizes cutting-edge technology over production volume. Projects take decades. Costs spiral. Numbers dwindle. The Liberty ship approach was opposite. Accept adequate technology, prioritize production speed, maximize numbers. That approach won World War II. Perhaps the most important lesson is the most obvious. When facing existential crisis, speed matters more than perfection. Britain was starving. The Soviet Union was collapsing. Every delayed ship meant lives lost and territory surrendered. In that context, Kaiser's approach, build adequate ships as fast as possible, was not just effective, but essential. Perfect ships that arrive too late don't save nations. Adequate ships that arrive in time do. 2007-10 adequate ships, built fast, won the Battle of the Atlantic. That's not the story of cutting-edge technology or brilliant tactics. It's the story of industrial capacity applied relentlessly to overcome a strategic threat. Sometimes the unglamorous answer, build more, faster, is the right answer. The Liberty ships were ugly, slow, and unsophisticated, but they floated, they carried cargo, and there were enough of them. That was sufficient, and sufficient, repeated at scale, changed the world.